This video clip is different from the others. I want to use it in a different way. I want to speak about this architecture conceptually and in a very broad way because it'll be the basis for some troubleshooting tools that I find very, very useful. We're seeing the worldwide internet, and then central to the diagram is one of these wired residential gateway devices that we've been discussing. It represents a DSL modem or a cable modem and a router and an Ethernet switch. Notice that I've expanded the LAN infrastructure with another pair of devices. Let's assume that the first one, the one closest to the router, is a hub, and the second one is an Ethernet switch. You can learn a lot more about hubs and Ethernet switches from other sections here at AskMisterWizard.com. The important thing to remember is that they're very similar, but a hub is dumber than a switch. A switch divides the Ethernet traffic among the various connectors, where a hub always broadcasts everything to everybody. It turns out that it's very useful to have a hub at the top end, or the internet end, of your LAN distribution system. Because it broadcasts everything to everybody, a hub is a great place to insert a wiretap. A wiretap is a useful thing for troubleshooting. The industry has evolved to produce readily available free tools, software tools that you can put inside a laptop or a convenient computer equipped with Ethernet that will allow you to monitor or wiretap all of the traffic on your network. And these tools are very powerful. So the architecture shown here is calculated to optimize that troubleshooting and monitoring role. We could connect a laptop computer into that hub, which is the one you see wired here, and then running software on that laptop computer, we can see all of the traffic coming into any of the other computers from or to the internet. Now, as you think about this architecture and this video clip, you need to pay attention to the things I'm not showing. I've purposely simplified this so that I'm not showing the other devices on this network. You might assume there could be dozens of other computers connected to that Ethernet switch or to the available ports on that hub, and we would be able to monitor all of the traffic that they exchange out on the worldwide internet. You might also assume that there's a Wi-Fi access point, or maybe a Wi-Fi router plugged in downstream. Again, plugging into either that hub or that switch. And once again, whenever they send traffic to the internet, it has to go through that hub. And whenever internet traffic comes back to any of them, it comes back through that hub, and the laptop PC running the wiretap or monitoring software would see and be able to analyze all of that traffic. No matter how many users there are in the local area network, all of their traffic goes through that hub because it's astride their default gateway out there in the DSL modem or in the wired residential gateway device. We'll see it all. This is very useful. So whenever I build a sophisticated network in a home or small office, if it's something I intend to use and grow and on which I expect to do experimental things, I always like to have a hub, the first thing plugged into my head-end router. And I never use, or I rarely use, any of the other connectors on that head-end router. So those three empty connectors you can see on that wired residential gateway device, they're empty in this video clip, and they would normally be empty all the time. I always do everything branching out from the hub because that gives me the opportunity to monitor. If something goes wrong with monitoring tools, I can then see and analyze it. The wiretapping or analysis or troubleshooting software to which I refer would run in that laptop as illustrated here in this video clip. The most popular one nowadays is named Wireshark. It's a free and open source application that anybody can download on the internet, and it runs well in most modern personal computers, either from Linux or Windows. There are others that are also good, and if you find a reference to an older version named Ethereal or Ethereal, it's the same thing. That's the granddaddy of all of these free open source analysis packages, they understand Ethernet really well, and they can break open an Ethernet frame, find the IP packet inside of it, and figure out what all of the fields and bits mean, unless the packet is encrypted. If the packet is encrypted, they'll still be able to analyze the structure and frame, but you won't know the contents. I hope at some time in the future to have a section here at AskMisterWizard.com on network troubleshooting that will include the details of Wireshark and the wonderful things you can do with it. But until that comes out, you could experiment with it on your own. It's easy to find Wireshark, download it, install it, and it's amazing what you can see and do. This is the architecture you want to develop to support it powerfully. So as I said, I want to use this architecture symbolically in a broad sense in any of the other architectures and video clips that I illustrate showing how to connect and grow a network. You can assume there's a hub in series with the initial router up at the top end near the internet connection. I don't always show that hub, but you can assume it's there. If it is there, it's transparent, it never hurts anybody, it just sits there, not affecting anybody, but allowing a wiretap so I can connect a troubleshooting computer there and see what's going on. It's just a good practice to have that. We may not discuss it further in other clips, but I usually have it there. For further information on hubs and switches, enough details to make this really useful, go back to the Networking Fundamentals section at AskMisterWizard.com. Find the Ethernet subsection, look at that table of contents on the left, and take a look at the free clips on Ethernet hubs and Ethernet switches. It'll give you the understanding you need, and this will all make good sense.